In my presentation, I try to say a different point of view about global warming. With this picture, you would say, oh, the poor bear. And you would think that we have to save the bear through stopping global warming. But I want to introduce this book, Cool It. Do you know Bjørn Lomborg? He is expert in climate change and professor in Copenhagen Business School. He claims that we are obsessed in stopping the global warming. He says if we spend big money in climate protection like Kyoto Protocol, it will have no impact. Kyoto Protocol can delay global warming only 5 days. What is the reason? The United States refused to participate in Kyoto Protocol. The United States is top-ranking country emitting CO2 like this graph, this blue box. There are some evidences on overstatement in global warming. First, how about the bear? Do you know how many polar bears die from global warming? Only 0.06 a year. On the other hand, 49 bears die from hunting. So if you want to save these bears, you must regulate hunting through law, not stopping global warming. Second, how about the disasters from global warming? You would think that if global warming continues, so many people will die from heavy rain and flood. But Bjørn Lomborg says that if we slow down global warming, over 10,000 people would die from cold. So we have to consider the positive effect of global warming. Now, what is his opinion about global warming? He says that there are so many overstatements in global warming. We have to solve other problems like famine, drinking water shortage rather than global warming. We can summarize his opinion like this. First, global warming is developing. Second, but we cannot solve global warming immediately. Third, before that, we can solve other problems to save life. Fourth, not obsessed with the overstatements about global warming. Thank you.
Hello, I'm Ji-Yoon Jung, and I'm sorry for that. I got a bad cold and my voice is not that good to hear, but please listen carefully. Okay, today I'm going to talk about something related to my major. It is how green is cotton comparing to polyester. Cotton and polyester are really friendly fibers. Even now, most of you are wearing cotton or polyester or a combination of them. So do I. As you can see here, they are two types of total fiber production. Cotton is the representative of natural fibers, and polyester is the representative of synthetic fibers. Which one is greener? I don't mean the color, you know. This green means eco-friendly. Here is a graph of global emission of cotton. It shows how much carbon dioxide emitted on each step, and here are three big emitters. So I focused on these three. Let's start here. The step of raw material. Cotton growing emits 4.7 kg CO2 per 1 kg cotton fibers. Unfortunately, it is also planned, so it can offset a little bit, but it still results in 3 kg net CO2 with global warming potential within cotton fiber production. And it has huge water footprint compared to no water needed in polyester production. Because polyester is man-made fiber, it needs many chemicals but no water. Cotton accounts for 24% of world's insecticide market and 11% of the sale of global pesticides. They cause pollution of surface water as well as groundwater. They are like poison to environment. How about the next step? Wet processing that includes bleaching, dyeing, and printing and finishing stages also need much water and waste and pollute it. Through our production steps, cotton requires about 9,900 liters of water per kilogram. And only to produce and supply that amount of water, 3 kilograms of CO2 is required. Also, 5% of that is just wasted. Here is a comparative table. We already talked about raw material and manufacturing step of cotton. Even if polyester is synthetic fiber, but there is only a little gap between two. When the transportation parts are added, total of there are same. Oh, sorry. The reason why the transportation energy of cotton is bigger might be this. Cotton requires larger area. The cultivation lands are separated over the world, so I think it makes cotton transportation to need more energy. Now we left only one. Let's look at the energy in use. Wow, you see? What happened with that gap? It's the biggest part of emission here. Okay, let's look what is the problem. It is caused by their own properties. First, absorbency. Do you know what is hydrophilic and hydrophobic? Hydrophilic means it likes water and hydrophobic means it hates water. For example, even if you put cotton shirt and polyester shirt together to wash machine, after cleaning, you will feel that cotton one wets more because it loves water. So it needs more energy to dry. Second, cotton has lower resilience. Resilience means resistant power against wrinkles. So lower resilience means it wrinkles easily and needs ironing. Then this ironing requires much energy too. Third, lower durability. Cotton wears out easier than polyester. We call that cotton has shorter lifetime. However, the product may be rejected before its physical lifetime is over due to visual factors such as the peeling effect on the shirts or due to changes in fashion trends. Peeling is little pore on the fabric surface caused by rubbing, like here on my shirt. Can you see? There are little pores on it. So the polyester is very weak to this peeling, so people throw away easily before it wears out. So this part can be ignored these days. But cotton still requires much more energy and CO2 when you use it. Now I ask you again, how green is cotton? Did you find the right answer? Thank you for listening.
태윤, I talk about La Nina. La Nina, meaning the little girl, names the appearance of cooler than normal waters in the eastern and central Pacific Oceans, sometimes called El Biejo, anti-El Nino, or simply a cold event. It is the antithesis of El Nino. La Nina is thought to occur due to increases in the strength of the normal patterns of trade wind circulation. Under normal conditions, this wind moves westward, carrying warm surface water to the Indonesia and Australia and allowing cooler water to upwell along the South America coast here. For reasons not yet fully understood, periodically these trade winds are strengthened, increasing the amount of cooler water toward the coast of South America and reducing water temperatures. The increased amount of cooler water toward the coast of South America causes increases in the deep cloud buildup toward Southeast Asia, resulting in wetter than normal conditions over Indonesia during the northern hemisphere. The changes in the tropical Pacific are accompanied by large modulations of the jet stream within the middle latitudes, shifting the point at which the stream normally crosses North America. The shifted jet stream contributes to large departures from the normal locations and strength of storm passes. The overall changes in the atmosphere result in temperature and precipitation anomalies over North America, which can persist for several months. effect of La Nina are more direct and dramatic during the northern hemisphere winter. La Ninas may affect weather patterns in certain parts of the world, causing anomaly high rainfall in the Southeast Asia. Here. And dry conditions in the desert areas of South America. Some impacts of previous La Ninas include 1. Abnormally heavy monsoons on the Indian subcontinent. Here. Torrential rains leading to floods in the Southeast Asia. Wet weather in eastern Australia. Here. Last cool and wet winter in southeastern Africa. Here. In the United States, colder and snowier winter in the northern states west of the Great Lakes. Drier than normal winter in the southeast. Here. Warmer and drier winters in the southwest. Here. Last, enhanced hurricanes activity around the mid-Atlantic states. That's all. Thank you.